Hey everyone, and welcome back to Key Safety Talks on YouTube. We know you're all busy out there, so we appreciate you taking the time to tune in. Whether you're on your commute, hitting the gym, or maybe even tackling that mountain of dishes. Today we're going to be diving into a topic that's essential for everyone, regardless of your profession: electrical safety.
That's right. And it's interesting because when we think about electrical safety, we often just focus on those immediate dangers like burns. But the truth is the long-term effects of electrical shock can be way more insidious.
It's almost like a hidden danger, isn't it? You hear about burns, but not so much about the potential for nerve damage or chronic pain, or even mental health issues like anxiety and depression stemming from an electrical shock.
Exactly. And these effects can linger for years, sometimes even a lifetime. We had the opportunity to speak with John Null, a journeyman electrician who shared his personal experience with this. Years after an electrical shock, he still grapples with debilitating pain and memory loss.
His story really highlights the importance of documenting every electrical shock, no matter how small it might seem at the time. You just never know what might surface later on.
That's so important. By documenting those shocks, even the seemingly minor ones, you create a record that can be crucial for medical professionals down the line. If you start experiencing health problems later on, that documentation can help connect the dots and ensure you receive the proper care.
It's all about being proactive and taking those small steps to protect yourself in the long run. Speaking of taking steps, let's talk about complacency for a minute. We've heard from so many experts that it's a major contributor to electrical accidents.
Complacency is that dangerous feeling of, it won't happen to me or we've always done it this way. But the reality is electricity doesn't care about your experience or your assumptions.
We heard a chilling story from Brandon Schroeder, a veteran electrician who had a near-fatal arc flash incident after 15 years of working with electricity. And he admitted that he'd fallen into a pattern of risky practices, thinking it couldn't happen to him. He described feeling the intense heat of the arc flash and the emotional toll of his long recovery. It's a stark reminder that complacency can affect anyone, even seasoned professionals.
And it connects to what Mike Barr, another expert we spoke with, calls known knowns. These are the hazards we encounter daily and become so familiar with that we start to uh, let our guard down.
Like coming into contact with overhead power lines, which is unfortunately the leading cause of electrical fatalities.
Right. We see those lines all the time. We know they're dangerous. But accidents still happen because that familiarity can breed a dangerous level of comfort.
So how do we combat that complacency? How do we stay vigilant, especially when we're dealing with those known knowns?
Mike Barr had a powerful statement about this. He said there's no such thing as a freak accident.
Interesting. What did he mean by that?
He argued that accidents happen when we fail to understand and respect the laws of electricity. He used the example of a crew who tried to ground an energized bus in a substation, a situation that could have been catastrophic.
Wait, so even seasoned professionals can make those kinds of mistakes?
Absolutely. It highlights that even with experience, a lack of understanding of the fundamentals can lead to serious accidents. It reinforces that continuous learning and a healthy respect for electricity are essential for everyone, regardless of their experience level.
So knowledge is power when it comes to electrical safety. We need to constantly challenge our assumptions and make sure we're operating from a place of understanding, not just habit.
Exactly. And that brings us to another common misconception: grounding. Many people believe that if something is grounded at the source, it's automatically safe to work on down the line.
That makes sense on the surface, but I'm guessing there's more to it.
There is. The reality is more complex. Imagine a jumper opening up in a circuit, creating two different ground potentials.
Okay, so now you have electricity flowing in unexpected ways.
Exactly. And this can create dangerous situations even if you think everything is properly grounded. It's like that common safety sticker. If it's not grounded, it's not dead.
Wait a minute, are you saying that sticker is wrong?
It's not necessarily wrong, but it's dangerously incomplete. Even if something is grounded, it can still be energized under certain circumstances.
So relying solely on that sticker could give you a false sense of security.
Precisely. It's crucial to understand how electricity flows and take the necessary precautions, regardless of what a sticker might say.
So always double check, use your meters, and never assume anything when it comes to electricity. Okay, let's shift gears a bit and talk about personal protective equipment, or PPE. When it comes to electrical work, PPE is absolutely essential. And one of the biggest points of confusion is the difference between AR and FR clothing.
You're right, that distinction can be tricky. AR stands for arc-rated and FR stands for flame-resistant. Think of it this way. All AR clothing is inherently FR. but not all FR clothing is AR.
Okay, so it's like the whole all squares are rectangles, but not all rectangles are squares thing.
Exactly. AR clothing is specifically designed to protect against the tremendous heat and energy released during an arc flash event. It's rigorously tested and assigned an arc thermal performance value, or ATPV, which indicates how much energy the fabric can withstand before failing.
So AR clothing is like a specialized shield against those mini explosions we talked about earlier.
Exactly. While FR clothing is designed to resist catching fire from a direct flame, it might not offer sufficient protection against the intense thermal energy of an arc flash.
Got it. So AR is definitely the way for electrical work. But is it something you should wear only when you know you're going to be dealing with high voltage equipment? Or should it be an everyday thing?
That's a great question. And there's a lot of debate about it in the industry. We spoke with Derek Sang, an expert in AR/FR clothing, and he
Uh,
strongly advocates for daily wear AR clothing, rather than just using it for specific tasks.
so ditch the idea of constantly putting on and taking off coveralls.
Exactly. He makes a compelling argument. He points out that I take that all away by taking that $10,000 and buying all your guys $1,000 worth of PPE for 1 month.
So investing in daily wear AR clothing for everyone can actually save money in the long run because you're not constantly buying task-specific gear.
Precisely. It streamlines the process, reduces the risk of forgetting to put on the proper PPE, and creates a consistent safety standard. Now let's shift our focus from individual responsibility to a broader perspective, building a culture of safety within an organization.
That's a critical point. Safety isn't just about individual actions. It's about creating an environment where everyone prioritizes it.
Absolutely. And leadership plays a massive role in this. You can't just have a safety program gathering dust on a shelf. You have to actively cultivate a culture where safety is woven into the fabric of the organization.
Right. It's about actions speaking louder than words.
Exactly. One expert we spoke with, Leaf, put it brilliantly. He said, it's like going to the gym and only reading the workout plan. You won't see any results unless you actually put in the work.
So true. You can have the best safety plan in the world, but if it's not being implemented and reinforced daily, it's essentially useless.
Exactly. So what does it mean to truly build a safety culture? It goes beyond just having a document. It's about leadership, setting the example, fostering open communication about safety concerns, and empowering workers to speak up when they see something unsafe.
It's about creating an environment where everyone feels comfortable prioritizing safety.
Right. Precisely, because at the end of the day, everyone deserves to go home safe and sound.
Absolutely. So we've covered a lot of ground here. We've talked about the hidden dangers of electrical shock, the dangers of complacency, the importance of documentation, and the crucial role of building a strong safety culture. But before we wrap up this part of our discussion, I want to leave our viewers with something to ponder. Remember what Mike Barr said. Imagine yourself as a component in an electrical circuit. You are just a resistor waiting to light up.
It's a powerful image, isn't it?
It really makes you think. We'll continue our exploration of electrical safety in the next part of this series. We'll delve into more technical aspects, share more insights from the experts, and equip you with even more knowledge to stay safe. Stay tuned.
Welcome back to Key Safety Talks on YouTube. Thanks for sticking with us as we continue to explore the world of electrical safety.
In the last part, we delved into some pretty heavy stuff. The often overlooked long-term health impacts of electrical shock, the insidious danger of complacency, and the importance of fostering a robust safety culture. Now I'm ready to unpack some of the technical aspects of electrical hazards.
That's a great idea. Having a solid understanding of how electricity behaves is crucial to truly grasping why these safety practices are so critical.
Okay, so let's jump right in with something that's probably on everyone's mind, especially after hearing Brandon Schroeder's story, arc flashes. Can you break down exactly what an arc flash is and why it's so dangerous?
An arc flash is essentially a sudden release of energy that happens when electricity jumps across a gap in a circuit. Imagine it like a miniature lightning bolt, but instead of striking from the sky, it erupts within electrical equipment.
So like a mini bolt of lightning trapped inside the equipment. That sounds intense.
It is, and one of the main reasons it's so dangerous is the extreme heat generated during an arc flash. We're talking temperatures that can exceed 35,000 degrees Fahrenheit.
Wow, 35,000 degrees. That's hotter than the surface of the sun.
It is, and that intense heat is just one of the hazards associated with an arc flash. It can cause severe burns, instantly ignite clothing, and even melt metal.
So it's not just the electrical shock itself that poses a danger, but also this explosive force of the arc flash.
Exactly. In fact, there are 3 primary dangers associated with an arc flash that you need to be aware of: thermal radiation, a pressure wave, and molten metal droplets. The thermal radiation is that intense heat we talked about, and it can cause serious burns, even if you're some distance away from the arc flash.
It radiates outward like a blast furnace.
You got it. Then there's the pressure wave, which is a powerful blast of air that can knock people off their feet and cause hearing damage. And lastly, you have molten metal droplets.
Molten metal droplets. Ouch.
Exactly. These are bits of superheated metal that get flung out during the arc flash, and they can cause severe burns and eye injuries.
So it's a triple threat. Heat force and flying molten metal. And that's why AR clothing is so critical, right? It's designed to protect against all three of those hazards.
Exactly. AR clothing acts as a shield against those intense forces. But it's important to remember that AR clothing is only effective if it's worn correctly, and in conjunction with other essential PPE like face shields, gloves, and insulated footwear.
So it's really a full-body protection system you need to be thinking about. Now let's shift gears a bit and talk about overloaded circuits. What makes them so risky, and how can we prevent them in the first place?
An overloaded circuit occurs when you're trying to draw more current through a circuit than it's designed to handle. This can cause the wires to overheat, which can lead to a dangerous situation, a fire.
So it's like trying to force too much water through a narrow pipe. Eventually, something's got to give.
That's a great analogy. And just like that pipe could burst under pressure, an overloaded electrical circuit can overheat and cause the insulation around the wires to melt, leading to a short circuit or a fire.
Okay, that makes sense.
Yeah.
So how can we avoid overloading circuits and prevent these dangerous situations?
The best way to prevent overloaded circuits is to be mindful of how much power you're drawing from each circuit. Don't plug too many appliances into a single outlet, especially high wattage appliances like space heaters, hair dryers, or microwaves.
So be strategic about what you're plugging in where.
Right. And if you start noticing that a circuit breaker is tripping frequently, that's a big red flag. It's a sign that the circuit is overloaded and you need to reduce the load on it to prevent a potential fire hazard.
Got it. It's all about respecting the limits of your electrical system. Now, you mentioned earlier the importance of understanding how electricity works. Can we dig a little deeper into that?
Yeah.
I know we touched on grounding, but I think it would be helpful to explore some of the basic principles, like the difference between series and parallel circuits.
Absolutely. Understanding the basics of electrical circuits is essential for recognizing and mitigating potential hazards. Let's start with resistance. Resistance is basically the opposition to the flow of electrical current.
So it's like friction in a mechanical system. The more resistance, the harder it is for the electricity to flow.
Exactly. Every component in an electrical circuit has some level of resistance, and the higher the resistance, the harder it is for the current to flow.
Okay, that makes sense. So how does resistance play out in series and parallel circuits?
In a series circuit, the components are connected in a single pathway, one after the other. Think of it like a chain. The current has to flow through each link in the chain.
Okay, I can visualize that.
The key point here is that the total resistance in a series circuit is simply the sum of the individual resistances of each component. So if you add more components to a series circuit, you increase the total resistance, and that can affect how much current flows through the circuit.
Got it. So more components, more resistance. What about parallel circuits?
In a parallel circuit, the components are connected on separate branches, which provides multiple pathways for the current to flow.
So it's like having multiple lanes on a highway instead of just a single road.
Precisely. And because the current has multiple paths to take, the total resistance in a parallel circuit is actually lower than the resistance of any individual component.
So adding more components in a parallel circuit actually decreases the total resistance. That's counterintuitive.
It is. And this is why parallel circuits are the standard for household wiring. They allow you to connect multiple appliances to a single circuit without overloading it.
That's fascinating. Now, I know we also talked briefly about capacitors and inductors. Could you give us a quick rundown of what those are and what roles they play in electrical circuits?
Sure. Capacitors and inductors are passive components that store energy, but they do so in different ways. A capacitor stores energy in an electric field, kind of like a tiny battery, while an inductor stores energy in a magnetic field.
So they're both energy storage devices, but with different storage mechanisms. What are some common uses for them in electrical circuits?
Capacitors are often used for filtering, smoothing out voltage fluctuations and blocking direct current or DC voltage. Think of them like little shock absorbers for your electrical circuits.
Okay, and what about inductors?
Inductors are often used for filtering, blocking high-frequency signals, and storing energy in magnetic fields. They're often found in things like transformers and motors.
So they play critical roles in regulating and controlling the flow of electricity. Now, we've covered a lot of technical information, but I want to bring it back to the real world and talk about some common electrical hazards that people might encounter in their everyday lives or on the job site.
That's a great idea. Understanding the theory is important, but being able to apply that knowledge to real-life situations is what keeps us safe.
Exactly. So let's start with something we all interact with regularly. Electrical cords. What are some common hazards associated with cords, and how can we avoid them?
Electrical cords can be a source of many hazards, including shocks, burns, and fires. One of the most common hazards is simply using damaged or frayed cords. You know those cords you see with exposed wires or cracked insulation?
Yeah, we've all seen those lurking around.
Those damaged areas create a shock hazard and increase the risk of a short circuit or fire. It's crucial to inspect your cords regularly and replace any that are damaged. Also, avoid running cords under rugs or furniture where they can be crushed, get overheated or damaged without you realizing it.
Out of sight, out of mind, but potentially dangerous. And it's also important to use the right cord for the job, right?
Absolutely. Using an undersized cord for a high wattage appliance can cause the cord to overheat and potentially start a fire. Always make sure the cord you're using is rated for the amperage and voltage of the appliance you're plugging in.
So always double check those labels. Now, what about extension cords? Are there any specific precautions we should take when using those?
Extension cords are great for temporary use, but they're not designed for long-term or permanent installations.
So they're not meant to be a band-aid for bad wiring.
Exactly. If you find yourself constantly relying on extension cords, it's a sign that you need to consult an electrician about adding more outlets. Also, never ever use extension cords that are damaged or frayed, and be mindful of the wattage limitations of both the cord and the outlet you're plugging it into.
Okay, so treat those extension cords with respect. Now let's talk about those overhead power lines we mentioned earlier. We know they're a leading cause of electrical fatalities. What are some specific things we can do to stay safe around them?
Overhead power lines are extremely dangerous, and the number one rule is to maintain a safe distance from them at all times. Always assume that all overhead power lines are energized, even if they don't look like they are.
So no touching, no climbing, no messing around.
Exactly. Keep yourself and any equipment like ladders or scaffolding at least 10 feet away from power lines. And if you have to work near power lines, extra caution is critical. Make sure everyone on the team is aware of the hazards and knows the safety protocols.
Right, it's a team effort when it comes to safety. Now let's zoom in a bit and talk about something that might seem harmless, but can actually be quite dangerous. Electrical outlets. What are some potential hazards associated with outlets? And how can we keep ourselves and our families safe?
Electrical outlets are a common source of shocks, especially for young children. It's crucial to make sure all outlets have those tamper-resistant covers. They prevent curious little fingers from inserting objects into the slots.
Those little plastic plugs can be lifesavers. I know I've definitely stopped my fair share of potential mishaps with them.
Absolutely. And if you have older outlets that don't have tamper-resistant covers, you can easily purchase outlet covers that fit over the entire outlet and plug into it. They provide an extra layer of protection and peace of mind.
That's a great tip. Now, what about those ground fault circuit interrupters, or GFCIs as they're more commonly known? Can you explain what those are and why they're so important?
GFCIs are specialized outlets that are designed to protect against electrical shocks. They work by detecting imbalances in the electrical current flowing through the circuit. If an imbalance is detected, the GFCI trips and interrupts the flow of electricity in milliseconds, preventing a potentially fatal shock.
So they're like super fast circuit breakers that are specifically designed to protect against shocks.
Exactly. They're incredibly sensitive and react much faster than a standard circuit breaker. GFCIs are typically required by code in areas where water is present, like bathrooms, kitchens, and outdoor spaces. But honestly, it's a smart move to install them in other areas of your home as well, especially if you have young children.
So consider GFCIs a must-have for any home.
Absolutely. They're relatively inexpensive, easy to install, and have the potential to save lives.
Great advice. Now, I know we've thrown a lot of information at our viewers today, from arc flashes and overloaded circuits to GFCIs and the nuances of electrical cords.
It's a lot to take in, but it's all crucial knowledge for staying safe around electricity.
Exactly. We'll be back for part 3 to wrap things up, share some key takeaways, and discuss concrete actions you can take to stay safe around electricity. Welcome back to Key Safety Talks on YouTube for the final part of our discussion on electrical safety.
Yeah, it's been quite a journey, hasn't it? We've covered a lot of ground from those often overlooked long-term consequences of electrical shock to the intricacies of electrical circuits and grounding.
We've debunked some common myths, heard some pretty powerful stories from those who have experienced the hazards firsthand, and learned a ton from the experts we've spoken with. But now let's distill it all down to the essentials. What are the key takeaways our viewers should remember as they navigate the world of electricity?
Well, I think the most crucial point is recognizing that complacency is the enemy when it comes to electrical safety. Never assume anything when working with electricity. Always double check, use your meters, and follow established safety procedures, even if you've done the task 1,000 times before.
It's so easy to just fall into a routine and let our guard down, but as we've heard, that's when accidents are most likely to happen.
Exactly. Another key takeaway is respecting the power of electricity, even when it seems benign. Even those seemingly minor shocks can have long-term health consequences that you might not notice immediately.
It's like a ticking time bomb, isn't it?
In a way, yes. And that's why it's so important to report all shocks, no matter how small they seem, and get them documented by a medical professional. Don't underestimate the potential for delayed symptoms or the value of having a record of the incident.
It's better to err on the side of caution and get checked out, even if you feel fine initially.
Absolutely. And speaking of being proactive, let's not forget about PPE. Investing in high-quality AR clothing and making it a part of your everyday workwear is essential, not just something you pull out for specific tasks.
It's like wearing your seatbelt every time you get in the car. You might not need it every time you drive, but it's there to protect you when you do.
That's a great analogy. And lastly, but certainly not least, remember that building a strong safety culture goes far beyond just checking boxes on a compliance checklist. It's about encouraging open communication where everyone feels empowered to speak up about safety concerns. And it starts with leadership setting the example.
It's about creating an environment where safety is everyone's responsibility, not just a top-down mandate.
Exactly. And to tie it all back to where we began, remember Mike Barr's challenge. Imagine yourself as a component in an electrical circuit. You are essentially a resistor waiting to light up.
That's a powerful image, and it really drives home the point that we need to understand how electricity works and take the necessary precautions to avoid becoming part of that circuit.
Electricity doesn't discriminate. It follows the laws of physics. And those laws are unforgiving. We need to respect those laws and work with them, not against them, to stay safe.
Well said. So to all of our viewers out there, be vigilant, stay informed, and prioritize safety in everything you do. Thanks for tuning in to Key Safety Talks, and we'll see you in the next episode.